Okay, this is a video on Lewis structures. Lewis structures, I believe, is section 9 point, I don't know, 9 point something. Hang on a second, let me look in the book. 9 point something, I don't know what section it is. Hang on a second. Quit bugging me. People crazy, bugging me all the time. Lewis structures. 9 point, no, not 4, not 5, 9.6. So Lewis structures 9.6. That's the video. This is on Lewis structures 9.6. Let me write the words down. Lewis structures. Lewis structures. We alluded to the Lewis structure in previous videos. Lewis structures, basically, my friends, are a way of showing the atoms in a molecule and the electrons, that are being shared between the central atom and the atoms bonded to it, and also the lone pairs that exist on both the central atom and the atoms that are bonded to it. And it's based upon the dots. So a Lewis structure is based upon the Lewis dots. So I'm going to teach you how to do a Lewis structure. And I have my own method of doing it. It's a little bit different than what some other people might do it, but I like my method. I think it works good. And I'm going to show you the steps. Well, I'm going to write down the steps. I'm going to speak the steps, but what I write is going to be abbreviated, so you might want to listen closely and maybe go back and rewrite what you hear as opposed to what you see. So the first thing you're going to do is you're going to take your molecule and you're going to count the total number of valence electrons. All right, so we're going to take a molecule, we're going to count the total number of valence electrons. So if we were going to do this example for, say, like F2, all right, how do we figure out the number of valence electrons? Well, it's based upon the group number. See, we're only going to stay in the representative elements. So based upon the group number in the representative elements, that's the number of valence electrons. So group 1A elements have 1 valence electron, and group 2A elements have 2 valence electrons, and that would be the two groups on the left on the periodic table. Then we're going to skip all of those transition metals in the middle and go all the way to the right, where group 3A has 3 valence electrons, group 4A has 4, 5A has 5, 6A has 6, 7A has 7, and group 8A, all the elements in group 8A have 8 with the exception of helium, which of course only has 2. So if we're going to do F2, we've got 7 from one fluorine, we've got 7 from the other fluorine. We have a total of 14 valence electrons. Number 2, we're going to arrange the 2, we're going to take them and we're going to draw the symbols of the elements, and we're going to draw those symbols and we're going to arrange them in some logical way. Now usually we start out with one particular atom being the central atom, and then all the other atoms that are bonded in this molecule are attached around it. Since this is only a 2-molecule or a 2-atom molecule, we basically would just put them next to each other. But I'll do some examples of showing how to put a central atom in first and then atoms around it. So you're going to do a logical arrangement. And again, that's based with one central atom in the middle. The element that we usually put in the middle for the central atom has the lowest electronegativity. So the one with the lowest electronegativity is usually the one that goes in the middle. There are some exceptions though. For example, hydrogen, because it's such a small element, can't make more than one bond. It can never go in the middle. So if its electronegativity is lower than the other elements, it can't go in the middle. Anything that's really small and has a lower electronegativity and can only make one bond can never go in the middle. Okay? So there's the second step. So first we count the total number of valence electrons, and we come up with a logical arrangement based upon the lowest electronegative element being in the center. All right, now back to our example. Number 3. All right, so we've got our F's in our logical arrangement. We know we've got 14 valence electrons. What we're going to do now is we're going to place a single bond. We're going to place a bond in between the two atoms. So we're going to place a bond 2 electrons between the central atom and each atom that's bonded to it. Okay, and we're going to put a single bond there, and we put a pair of electrons in between, and now of the 14 valence electrons that we've had, we only have 12 left. Now in the next step, we're going to arrange the remaining valence electrons around the atom following the octet rule. Now, what is the octet rule? Well, we kind of alluded to it before because we said that representative elements are trying to get 8 valence electrons. So the octet rule is that they're trying to have 8 valence electrons around it. So we're going to take the remaining valence electrons, we're going to arrange them around each of the atoms in the molecule following the octet rule. So I like to do this in terms of pairs. So I will place pairs around the particular atoms, starting with the atoms on the outside first and then moving into the central atom, making sure that everybody has 8 around it with the exception of our good friend hydrogen, which only wants 2. So let's try that. So here's our F. We've got the pair of electrons in between, and we used 2 of the 14, so that means we have 12 left. So we're going to go 2, 4, 6, 8, 10, 12. So we've used all 14 valence electrons. The fluorine follows the octet rule, and the other fluorine follows the octet rule, and we're all good to go. All right. Last step, and I forget which number it is, so you tell me. What number is that? Anyway, it might be 5. Could be 6. Who knows? Last step, or last thing to consider, at least anyway. If you don't have enough electrons to get a noble gas configuration or 8 valence electrons or following the octet rule around each atom, you're going to have to make multiple bonds. Okay? Or if you have too many electrons, you need to put them on the central atom. And in another video, you're going to see more about this, okay? So let's do an example. Let's do another example. Let's say we wanted to do CI3. Sorry, not 3, 4. Sorry about that. Make that CI4. So let's say we wanted to do CI4. Okay. So first we said count the number of valence electrons. Carbon has 4. Each iodine has 7, and 4 times 7, right? So the total is 28 plus 4, that's 32. Now we said take one of the elements and put it in the center, and let's pick the one that has the least electronegativity, and that actually ends up being carbon. And then we're going to arrange the rest of them around it in some logical manner, so I'm going to arrange it like this. One on the left, one on the right, one on the top, one on the bottom. Then we said put a single pair of electrons, a single covalent bond in between. There's 1 pair. There's 2. There's 4. There's 6. So we've got a total of 8 valence electrons that we used up. And we put a single bond in between each, right? So we used up 8 of the valence electrons. We're going to take 8 away. We've got 24 left. Now we're going to arrange the remaining 24 around this in pairs in such a way so that everybody has 8. Well, the carbon already has 8, so let's put the rest around the iodines. So that's 6, 8, 10, 12, 14, 16, 18, 20, 22. So there's the remaining 22 that we used up, right? See, I probably miscounted. 2, 4, 6, 8, 10. Oop, there we go. 12, 14, 16, 18, 20, 22, 24. So there's the remaining 24. Everybody has 8. There's the Lewis structure for this molecule. Okay, going to do one more example because we're trying to keep these videos short. We'll show you a case in which you need to form multiple bonds. So let's say we're doing O2, all right? So let's count up the number of oxygens as 2. Each one has 6 valence electrons for a total of 12. So we've got 12 valence electrons. And again, we would put one atom in the center, the one with the lowest electronegativity, but since this is a 2-atom system, obviously the only logical arrangement is one on the left, one on the right, or one up or one down. It's up to you. We're going to put a pair of electrons in the middle, like so, and that's going to give us 10 left. So we're going to arrange those 10 in pairs in order to try to get 8 on everybody, following the octet rule. 2, 4, 6, 8, 10. Well, this oxygen on the left is happy, but the oxygen on the right is not, because it doesn't have 8 valence electrons. The one on the left does, the one on the right does not. So maybe we can take these and move them from there, put them over here. Now the one on the right is happy, but the one on the left is not. You see, we don't have enough electrons to establish 8 valence electrons on each, so this is where we have to start forming multiple bonds. So I would take that extra pair of electrons, put it in the middle, like so, forming 2 bonds, or a double bond, and we see now that this oxygen has 8, 2, 4, 6, 8, and this oxygen now also has 8, 2, 4, 6, 6, 6, 8. There you go. Now everybody's got 8 valence electrons. So when we get to a point where we don't have enough electrons, we start moving them in to form multiple bonds. Okay, so that's the video. I know we kind of did this quickly because we try to keep them short. Try the problems. If you have any questions, you can also take a look in the text, or you can see myself or Mr. Walsh tomorrow. All right, my friends, have a good one.